And finally, the final method that we're going to talk about to solve quadratics is the quadratic formula. Now, I may have misspoken earlier with factor by grouping, but one of the cool things about the quadratic formula and completing the square is that it works for any quadratic. And simple factoring is very quick and it's nice when it works, and factor by grouping is valuable and also fairly quick when it works, but they only work if your question can factor. The quadratic formula and completing the square do not need that requirement. You will be able to solve any equation in that form. And this one's kind of nice because it's a little bit more computation heavy, which means you're going to plug in some values and do order of operations, but it's still valuable and very quick. And if you go into like anything with computers, it's nice to be able to use a formula and plug in a lot of values instead of having to kind of struggle with the concepts of what completing the square actually means in each individual step. So a lot of students really like this, but that's not to mean that completing the square isn't valuable. Honestly, if I had you guys only learn one of them, I would say make sure you're really good with completing the square. That being said, this is valuable. That was long-winded. Anyways, so I mentioned, or at least I've displayed on a couple of slides and mentioned offhandedly, but I should explicitly say it. This is the definition of a quadratic equation. I need to have an ax squared plus bx plus c is equal to 0. Otherwise, it's not really a quadratic equation. And yes, when we're using completing the square, we move to the other side. If we're using the move c to the other side, if we're using quadratic formula, we need to make sure we have everything on the same side of the equation. So if I'm asked to use the quadratic formula in this question, I have 2x squared plus 16x is equal to -5. Well, I can't do that because I don't have a 0 on one side and I don't have everything to the other side. So in order to use the quadratic formula, my first step is to add 5 to both sides. And now I have 2x squared plus 16x plus 5 is equal to 0. And this next step is a little bit involved, but all I'm really doing is I'm taking that formula that I have boxed and I'm putting everything in the correct spot. So I'm going to put in 2 everywhere I have an A, I'm going to put in 16 everywhere I have a B, and I'm going to put in 5 everywhere I have a C. And so what that will look like is this. And then from there on out, if I'm trying to solve for x, I'm just going to do order of operations. So I'm going to square my 16, and I'm going to multiply my 5 times 2 times, or 4 times 2 times 5. So I have a square root of 256 minus 40, all square rooted, and then negative 16 plus or minus all over 4. Well, I'm going to subtract those things in the square root. I guess not in that step, in this step. So I subtract things under the square root, and now I'm going to stop. Because, well, square root of 216 isn't a really nice number. Again, if it was, let's say that was the square root of 16, well, yeah, you should find what that is. That's 4. You should do the plus and the minus thing that we saw with completing the square. You should go through the last couple of steps to get the actual solutions. But if you can't do that, that's perfectly fine. Don't round. Don't get me weird answers unless you're doing an applied problem. Just stop there and that's your answer. But that's the process. It's pretty much, I think my high school teacher called it plugging and chugging. All you're doing is plugging in values into the quadratic formula, and then you're following order of operations until you either get a solid answer or you get everything simplified as possible and you can't take the square root of that number, and so you'd stop like we saw here.